Hello, I am Andres. I am the maker of the Defold Platformer Creation Kit, and I'll try to make a video shortly demonstrating how a person could use this kit. So yeah, let's start. This is the main default window. We can see the editor here, the project explorer, the outline, and the properties for an object. We also have a log here and files that has been changed in our workspace. So when we start working with this kit, the only thing that we'll be able to see when we start when we build the project is the main menu, which has two buttons: the start game and quit button, and also the game title that the person who's working with the kit can change. So if we press the quit button, the game quits, of course, and if we press the start game button, nothing happens. It's because we haven't set up our main level scene. So you can see here it is empty. So starting, I guess, we can add, starting work, we can add a simple platform. So yeah, so you right click on the collection, you click add game object file, and you look for a platform. Currently we have two types of platforms. It's a platform, this simple rock with some grass on it, and a cloud platform. These both platforms are navigatable by the player and the enemy that can be placed in the scene. So we have these two platforms. The next thing we might need is the actual hero. So we once again add a new game object. We find the hero. Currently, I'd recommend using the hero game object that is under Platformer Creation Kit content, Platform Creation Kit, and hero folder. The other one is a spine model hero. It's currently only a test object, so I don't recommend using it. So yeah, so the hero one, we click and we have ourselves our hero. Yeah, we place it wherever we want him to be. And now if we play the game, we will still see that there's nothing. Well, we see a part of the platform here, of the cloud platform, but we don't see our hero. I think we can move him, but as you can see, the camera is not chasing our player. So for it to chase the player, for the camera to chase the player, we actually need to place a custom camera in the main collection. So we do that by also adding the game object and looking for a camera game object. We find it, we place it here, and we have the camera and the script that controls some of the camera's parameters. So now, if everything's correct, when we build the game, we start the game, and the camera is following the player. You can see when moving left or right, the camera stays with the player. So now for some camera properties, as you saw, the hero is quite big in the screen. Maybe we would like to see more of the hero's surroundings rather than more of him. So with some of the parameters like render scale, we can scale it up to, let's say, 2. I've found that using 2 is pretty nice, and we see that the hero becomes smaller in the screen space, and we see more of his surroundings. So yeah, talking about parameters, the hero object has plenty of them. We have a archer script put on him, which controls his ability to use his bow and arrow, shoot with it. You can uh, set up how many seconds it takes for every arrow shot, how fast the arrow moves, and at which initial direction the arrow should face. And we have a helper script that helps the camera object keep track of the hero. Then we have a health script which controls how many health the player has, let's say 5. Also, whether picked up health potions should that increases maximum health should increase the hero's health, and whether this particular health script belongs to the player. Next is the input script that exposes no parameters, because usually the designer shouldn't care about that, only in the project settings. And we also have the movement script, which has plenty of properties, from move acceleration, tells whether he can sprint, how much does the sprint change his speed, how much he can move, change his movement direction in air, how far he jumps, the gravity, how fast he goes, the gravity, how far he jumps, how far he gets knocked back, and so on. So yeah, that's the movement script. Now talking about the health, as you see, there is no indication, we can't see no indication of how much health our hero has, right? So to change that, we also add a simple game object. It's called health HUD, which means health heads up display. So we add it to the game. It has a GUI, graphical user interface object component on it, and now if we build the player, we press start, and we see that there's these 5 red balls that indicate how much the player has, how much health the player has. Yes. So now, moving on, we can add a potion. As I was talking about, I mentioned a potion before. So yeah, we have a potion. It has minimal properties. As part of a pickup, he can tell how much health it heals the player once picked up, and should it affect max health. If ticked, and this checkbox controls whether picking up the potion increases the max health. You can see if once I pick it up, the health increases, the max health increases. And yeah. Next thing, we'll add a enemy. We add more space here, and to add a simple enemy, we have a walking enemy game object. We add it. We see him up here on the screen here. Oops. Here we have this black creature up here on the screen. We can place him down wherever we want, like the player. He also has some scripts attached to him. I'm sorry. It has a artificial intelligence script, health script, and a movement script. The movement script is identical to the player one. Yeah, and you also can change all the parameters, how fast he moves, how far he jumps, and so on. His health script is also identical to the player. You can change how much health he has, and whether, well, this actually does nothing for him because he can't pick up potions, and it's important that he would not be I wouldn't have this player checkbox checked, because if he dies, then the player will see the end game screen. Yeah, so moving to more interesting part of the enemy, what changes from the player is the artificial intelligence script, which basically controls how the enemy should behave. These two vector vector 3 parameters tell how at which place relative to the game object the collision box center is, and how big the collision box is. It's basically used for doing some collision checks in the artificial intelligence code, and they should be identical to the collision box that appears around the enemy. So let's build the game, and we can see that now the enemy does absolutely nothing. We see he does not move, he does not jump, does nothing. But still, if we move close to him, he will damage us. We start blinking, and we lose a life point. So to add some life to the enemy, we can use some of his properties. So a couple of them are the follow player property, which is when checked, the enemy will start chasing the player once the player comes into 500 pixels within range of the enemy. Yeah, so we can see how this works. We check the follow player checkbox, we start the game, and we move close to the enemy, and you see he starts moving towards me. Next behavior he has is the patrol behavior, which makes him move forward, and once he hits some obstacle, he moves back to he starts moving the other direction until he hits an obstacle, and then moves back again, and so forth, and so on and so forth. Now, if we build a game, he will walk off the ledge because there's no obstacles for him to check. I'm planning to add a different behavior that once well, of course, customizable behavior is when he reaches the edge, he might decide whether to jump off the edge or turn back as if it was an obstacle. So now, to demonstrate how he turns back, we will add another platform here, and we'll raise this one up here. Now, if we build there, okay, it does not move. He probably something wrong with the code. Well, I'll have to check it out later. Anyways, moving on, we have this provocable parameter, which basically controls whether the enemy should attack the player once he gets hit by the player. So we can, with it checked, we can see how he reacts. So I clip him, and he starts moving towards me. At first, he will try to get to my place, and he'll find me and start chasing me. Anyways, so that's what the provocable parameter does. Now this of course tells what's the distance between what has to be the distance between the player and the enemy for him to start chasing, the maximum distance, and also it tells which is the minimum distance that the player has to reach from the enemy, that the enemy would stop chasing him with this checkbox set. That means that if the player gets away from the enemy in 500 units, the creature here, he will stop chasing the hero. Anyways, moving on, we have another little system here set up. It's the speech system, which basically allows the characters in the scene speak their mind. So we can see how this works is we add a game object, we call it a speech controller. Then we add a component from a file. It's called, the one we need is the speech controller script, and a speech bubbles graphical user interface. So yeah, these two control. This script controls all the speaking the player or any other character does, and the graphical user interface component just handles the displaying of the text and the speech bubbles. So now, really, when starting the game, it has no effect. The speech controller game object. For speeches to happen, for characters to speak their mind, we have to use entry points for them, which are in the shape of speech triggers. Now, a speech trigger is a simple box that can be triggered by a player, by the hero character. The speech trigger has a simple script, speech trigger script, which has a single property, which is a speech content identifier. So how this works is that in the speech controller, we have this here list of entries which control what a certain character says. Now, let's see this case of let's say we set the speech trigger to trigger the first entry in the speech content ID, right? You save, we build, and we'll have to reach this part here, this trigger, to actually start speaking the words. So let's see. We move here, and here we are. So the player says, I'm here to defeat all the monsters. He has to find them first. And there's some tips of how to move the player. So we move with the A and D or left and arrow keys. We move them, the hero, left and right. So how does this happen? So in the speech controller script, we have this data entries. You see the ID that I wrote in the speech trigger here. That's number 1 here. That's number 1 here. Now, this basically says it has 4 data fields in the entry, which is the duration of the spoken words. The target is the character who is saying those words, and the content is what he is saying, and the next field tells which, if any, words should be spoken next. So you see the next property here is 2, and the program looks for the second index entry in the speech content list here, and it finds it, and it automatically triggers it. So as we saw, the hero was there to defeat all the monsters. he first had to find them, and then he told us how to move. And if we set the next value to nil, which basically means it's pointing to nothing, the chain of speech will be ended. So as an example, I guess we can change this hello world, let's say, and let's add this to nil, and oops, we build and we start the game and we trigger, and here it says hello world and it just disappears. Now the one important thing is the target here has to correspond, well, it has to the name of it has to be in the main collection. Let's say we see the hero here, and it's the target of these spoken words. So the hero, we find it here, the program finds him, and it shows it as his spoken words. We can also force the enemy to speak. Let's say here's the walking enemy. We have this trigger, let's say, and we force him to say simply roar, and walking enemy. Oops. Here. We play, we start the game, we walk, and he roars, you see? So that's how the speech works. And that's basically the end of this simple demo. So yeah, what's ahead of us is probably making polishing everything, like making the patrolling actually work, which it did for some reason. It doesn't during the demonstration, and adding scene management, that the designers could easily change levels between when let's say wind conditions are met among our current level, and so on. So I hope this was informative, and see you next time, I guess.